Hi everybody, this is Stephen Pugh doing another installment in the City and Guilds Carpentry and Joinery course. Today we're going to be looking at the subject of roof structure and pitch roofs in particular. So on a pitch roof, there are a number of components. We need to talk about all those. I'll just reel them off. It's important for you to have a look at some pictures. You can find them on Google easy enough, or you can find them in the textbook for this course. And we're just going to talk about them very, very briefly and then pass on. So we've got the hip rafter. Now the hip rafter is that long rafter on the corner of a building that's much deeper than normal and which goes from the corner up towards an apex. And that's the hip rafter. We also have the ordinary rafter, the common rafter. We have the ridge board. Sometimes the ridge board is very thin. It's called a board. Sometimes it's bigger, so it's called a ridge beam. And then we have the cripple jack rafter. Now that sounds very complicated. It's a rafter that comes down from the ridge down to the side of a valley. Okay, a valley board or a valley rafter. And then we have the wall plate, and we have jack rafters. Jack rafters are the ones that come down from a hip down to the wall plate. So there's some of the basics. We've also got the purlin. And we've also got the verge, and we've also got the eaves. The eaves is where a roof coming down joins a wall coming up. That's called the eaves. And we've got the common rafter. We've also got what's called the crown rafter. Now in America, it's called the king rafter, but still doesn't really matter. The point is it's the same rafter. So this gives us some of the main components of constructing a roof. One of the most important things to really understand and to appreciate is what's called the bird's mouth. And the bird's mouth is a small cutout in a rafter that's coming down. There's a vertical cut, which is called the plumb cut, because it's always plumb. And there's the seat cut, which is a cut that fits on top of the wall plate. Okay, it rests on the wall plate, and it must be a good tight fit. There shouldn't really be any gaps on it. It should be nice and flat. So that's called the bird's mouth, and the bird's mouth comes across the thickness of the rafter, anything between a quarter and a third. People talk about a third today, but when I was younger, it was always a quarter of the depth. And then we have another plumb cut at the end of the rafter on the tail. That's also got a plumb cut, and it's also got a seat cut. We normally would cut the seat cuts on a rafter before they're actually put into place. It's very difficult to do a horizontal cut accurately by hand, whereas the plumb cuts are always relatively easy to cut. So there we are. There's all the main items on a roof. There's also another thing called the collar tie. Now, it's called the collar tie in the book. I was always taught that this was called the roof tie, and this is a horizontal beam which ties in the whole of the open structure. When a structure is like that, there's a tendency for the weight to cause it to do this, to come downwards. So by putting a collar tie across the bottom, it turns it into a triangle, which then is very stable. Okay, there's all the main components of a roof. Now, in construction methods for roofing, there's different types of roof, and we're going to just name them and describe them just now. A single roof comprises of common rafters spanning from a wall to wall, okay, without any intermediate support. Now, the most common place that you'd see these is on a small porch or on a very small building or a shed, but you wouldn't see them on a major structure because the amount of weight on the roof would cause it to open like that. And so therefore, the next type of roof we have is called the couple roof. Now, a couple roof is where it has a roof tie, or it has a collar tie, as some people call it, which actually ties the whole structure together. Close couple roofing is another type again, this is where the tie is a little higher. It's taken up a little bit higher, so it isn't quite at the bottom, but it's brought up a little bit higher. And because it's closer to the ridge, it makes it much stronger indeed. And then we have the collar tie roof. Let me just check that. Yes, that's a close couple. So a collar tie roof is another type of roof in which there is not only a tie going across, but there is a vertical going upwards. So that therefore that ceiling joist that's going across here, or we call it the roof tie or the collar tie, that ceiling joist is actually supporting the roof, and the roof is supporting it. So they're supporting one another, and they're also turning a small triangle shape of the whole roof. These roof ties or collar ties are traditionally bolted together. We don't just rely upon a few nails. We have some proper bolts that are wound up nice and tight, and that produces a very strong structure. And then we have what's called double roofs. Now, a double roof is a roof just the same. It may have a roof tie. It may also have a single span. It may have an intermediate wall going up to the collar tie or to the roof tie. And what that means is we have a triangle here, of course. We also have a vertical braces in various ways, and then we have a supporting wall in the middle. So that's a double roof. So you've got two double spans on a roof. Those from that span, we can then take up some struts for a purlin. Now, a purlin is a substantial joist that goes along the sides of a building. There's your building, and across here there are purlins that travel all the way down the length. And there's two different orientations for those purlins. You can either have them vertical, so there's your roof, you have them vertical, or you can have them on their side. Having them on this side means that they have a much better way of supporting the rafters. There's also another version, which is a triple roof. A triple roof is a roof structure in which there are large trusses erected, okay, and these trusses are usually called Kingpost roof trusses. You see them in big ancient buildings, in churches, for example, or big open, where there's a very solid truss, okay, all made out of very strong timber, and then in between this one and the next one, there's purlins going across, and these purlins go across, and then the rafters are laid on top of the purlins. So that really is a very old and ancient version of triple roof construction. Now we need to talk about the setting out of common rafters. There's a tremendous amount of technicality about setting out common rafters, and people talk a lot about all the complications of it. It is, funnily enough, a very simple process. The roof is measured not by the underside or by the top side of the rafter, not this side or that side. It's measured by that line, which starts at the bird's mouth and goes all the way up to the top of the ridge board. That is the place in which you measure a rafter. Now, some people may say, well, it's just the same measuring from the very top of the rafter coming down and then going down on a plumb cut. Well, that's very true. It is the same length. But the important thing is that we measure from the point of the wall plate, from the point of the bird's mouth, going right the way up to the ridge board. It's one of these things which is much easier to actually do in real life than it is to do in calculations. A lot of people have a lot of different calculations, and they have lots of different mechanical methods and mathematical methods to work out. My preferred method, and I've always stuck to this all my life, is to not keep away from the maths, and keep away from the technicalities, and to measure what I call in situ. What I mean by that is this. You know what it's like when you want to measure something. You need to measure a piece of wood. You can put the tape measure across it, try and read the number. Oh yes, it's 523, and then you remember the number, and then you put the tape measure on the wood and you measure 524, and you think, hang on a minute, was it 24 or 23? So you can make a mistake in remembering it, you can make a mistake in measuring it, and you can make a mistake in transferring the measurement. There's three mistakes you can make straight away. So I prefer, and I've always been taught to not do it this way, to not rely upon memory and to rely upon tape measures. In fact, whenever I got my tape measure out, my colleagues who were teaching me the trade used to start laughing. Put your tape away. You don't need the tape. If you can manage without the tape, you're going to be far better. And I said, well, how can I measure something without a tape? And they said, just pick the wood up and put it into place and put a mark. That. Very often, we would come to the end of a job and we didn't even know what the sizes of anything were. We just put the wood against the place where it was to be fitted, put a mark and cut it on the mark. Was there a mistake in measurement? No, because we never even measured it. And the same can be true with a lot of roof construction. It's possible when you're looking at, for example, a full-scale roof, when you go to a roof, if it's a cut roof in particular, you'll have the wall plates laid in place. And you can treat that wall plate as if it is a full-scale drawing. So you can measure down both sides, down to the height of the roof, and then that's where you put the marks for your wall plate. And then you measure across to the middle of the roof, and that's where you put your piece of ridge board. You can cut a little piece of the ridge board off and put it there, stand it up, and then mark each side of it, and that becomes the ridge board. And then you can take your, and you can do the same with your little wall plates. You can take a little offcut and put it on top of the actual main wall plate, and you've created a full-scale drawing, effectively, of the roof. Then what you can then do is put your timber actually in place, adjust it to where you want it to be, put it exactly where you want it to be, put the marks on your timber, and then you take that away and you cut it, and you might cut the other one on the other side as well. And then you can put those two pieces up and you can see whether they work perfectly. And then when you've done it in the real like that, there's very few errors that can actually occur. Very few errors indeed. So marking in situ and cutting to fit in situ is a much preferred method. The other thing to bear in mind is that you're working at a height. Sometimes, very occasionally, these roof constructions are designed and made to be made on the floor. So the whole of the roof will be made on the floor, all tied together, all strapped together, everything else. And a crane comes along and picks it up and puts it on top of the building, and then you go around and fix it. That's a much superior way of working, although you've got the cost of the crane, of course. But another way of doing it is to have various safety devices. And you can have, for example, you can have fall arrest equipment. So this is strapping that you wear, and if you fall, it will not let you go all the way to the ground, but it will actually slowly stop you as you're falling. So you end up suspended in midair, but at least you didn't hit the ground. Another way, of course, is working at height is to have proper scaffolding. So when you're standing on the scaffolding, you're able to reach out and do all of the necessary work. In America, it's not like that at all. They don't really rely on scaffolding as much, and they literally just climb up on the roof and work on it. But that, of course, as you can imagine, is highly dangerous, because even though they're very confident and they have a good head for heights, nevertheless, if they do fall, then it almost certainly is very catastrophic. We don't allow that in this country. There are other ways of arresting your fall. One is to have blow-up bags, but lots of them all around, all inside the building and just on the outside, in which if you fall, you just fall down into a bag full of air. But these things are not designed for getting off the building when it's lunchtime. They're designed only for emergency use. So all the normal procedures need to be followed when you're working at a height like that. You need to be careful about tying ladders properly. You need to be careful about the scaffolding being correct, making sure that the scaffolding has braces, it has kickboards, it has handrails, it has all of those features. The scaffolding by itself, by its very nature, is a dangerous thing to be. You're high up, and it's something that's been constructed high up. And so therefore you need to take the utmost care to make sure that you remain safe at all times. So there you are. We'll look forward to talking to you next time. We're going to talk next about a close couple gable ended roof. So see you next time. Bye for now.